Our warm-up problems. We have one of four different types. So, first one, standard form, which we talked about on the last lesson. Find the intercepts. Again, that was the last lesson as well. And then these ones here are review. Now, just a reminder, standard form, ax plus by equals c. All right, when we want an equation of a line, we want it in this form, y equals mx plus b. Whenever we have a point slope, y minus y1 equals m times x minus x1. And then lastly, if we want to find slope, y2 minus y1 over x2 minus x1. Okay? So first one, we want to get it in standard form. So we got to get all our variables on the same side. So I'm going to subtract a 2x from both sides. And that's going to give me negative 2x plus y is equal to 5. Now what's the problem with that?
Oh, there's negatives in
There's a negative in front of the 2. Two things we want to make sure of. One, we got to make sure both of these numbers in front of our variables are not fractions. And two, we got to make sure our a term is positive. So in this case, we have the positive or the whole numbers, but we don't have a positive, so we want to multiply everything by negative 1. It's going to give me 2x minus y equals negative 5. And that looks like the same as you had. Good. All right, second one. If we want to find the intercepts, we use the cover-up method. Use the cover-up method, make two columns, an x column and a y column. All right, so from there, cover up your y term. So for x, I'm going to have 4x equals negative 40. Divide both sides by 4. X is negative 10. Y side, cover up your x term. So you have negative 5y equals negative 40. So y is going to be positive 8. Now, I think that answer is 75% right. What are we missing? Points, right? Make it a point. So your x point is going to be negative 10, 0. And then your y point is 0, 8. There's a little bit, yeah. All right, so there's my 2 points. My two intercepts are negative 10, 0, and 0, 8. All right, so then find the equation of the line. Two things we need to write an equation of the line. We need a point, we need a slope. We're going to use this more today as well. All right, so in number 3, we have a point, we have a slope. So let's put it into point slope form. So I'm going to have y minus my y term equals my slope, x minus my x term. Okay? Looks like he has the same thing there. Okay, then just simplify. So y minus 4 equals negative 1/2 x plus 1. And then add the 4 over. So y equals negative 1/2 x plus 5. Okay? Last one. We have to find our slope first. So to find your slope, use your slope formula. So I'm going to have a slope of 11 minus 5 over negative 2 minus 0. So this is going to be 6 over negative 2. So my slope is going to be negative 3. Okay, then use that in one of my points. It doesn't matter which point I use, so let's just use 0, 5. Looks like that's the one he used as well. So y minus my y term equals my slope, x minus my x term. This comes out fairly easy for us, so y minus 5 equals negative 3x, because negative 3 times 0 then would be 0. And then add the 5 across, so y equals negative 3x plus 5. So what we got? Yeah, I think so. All right, any questions on that, guys? Questions on the homework? Okay, here's today's lesson. Parallel perpendicular lines. Parallel and perpendicular lines. This should make you feel a little bit like to elementary school S. Yeah. All right. So I would. Okay, parallel and perpendicular lines. Like I said, we got two left. We have parallel and perpendicular lines is 5, 6. 5, 7 is going to be scatter plots and trend lines. And then we are ready for a test after that. Test. I'm hoping we can take the test in person. My goal right now is do this lesson today, next lesson the beginning of next week on Monday, Thursday we would review, following Monday we take the test. That's my goal. That's if we stay in school. You do or don't? Well, we weren't here yesterday, so. All right, so we got 1, 2, 6 people. All right, tell me what are parallel lines in your own words? I didn't point at you.
What does that mean? Two straight lines next to each other at one time.
Okay, so he says straight lines next to each other. Okay, you wouldn't necessarily have to write these guys. I'm just kind of writing down what we say. SB, what do you think? Okay, go on forever. No touch. Anything you want to add to it? No, nothing to add.
Two lines that go on forever, and they stay the same. They stay the same. They stay the same part, far apart.
Same distance apart.
Yeah. And they never stop.
Okay.
Unless they ever go.
So they go on forever. All right. All right. What else we got? 2 of you left. Anything to add to it? No. No. All right. That's pretty decent. Okay. A lot of people said the train tracks.
Yeah.
You guys learned that in elementary school. I think every year someone says train tracks. I was surprised that didn't come. All right, so let's go the formal definition. So parallel lines are lines that never intersect. It's just basic, okay? Lines that never intersect. So it is correct that they'll run kind of side by side. The distance between them will stay the same the whole time. But one of the key things for us is when we're talking about the equation of lines is this. Parallel lines have slopes that are equal. Okay? Make sure you have that on there now. Put a little star beside that. Anytime you have parallel lines, the slopes of the parallel lines have to be equal to each other. Okay, so right here's the key point.
How do you draw your stars? Are they from the corner, from like the bottom left corner, or? I do too.
All right, questions on parallel lines? All right, you just wanted a very basic definition here. I paraphrased it down, but again, the big thing, we make sure we know parallel lines have slopes that are equal. All right, so the next thing, what are perpendicular lines? Start on this side. What's perpendicular lines?
I don't know.
Okay, so we have perpendicular lines.
Are there lines that cross?
Lines across, okay. Add to it.
Lines that vary in the distance between. I've heard this word before. What a line. Yeah, you got it right.
All right, so we did pretty good on parallel. Perpendicular was a little rough. Okay? I know you've heard it before. So perpendicular lines, maybe if I do this, it might bring back a little something.
No.
That's the intersection where they keep them, you shall do.
Where my dad wrecked his weight.
So- Looking at these, I'm going to say no. Yeah, they do cross. Yeah, this next one, vary the distance. I don't know about that. We'll put question mark on that one. No, yeah, lines. Well, yeah, hey, it's obviously lines. Again, they don't have equal slopes. Okay, it's a little rough. All right, so here we go. Here's the definition. Perpendicular lines are lines that intersect at exactly one point, and they make a right angle where they do. And perpendicular lines have slopes that have a product of -1, or they are opposite reciprocals of each other. There's perpendicular lines. That's what they look like. All right. The most basic way to look at perpendicular lines is look at the x and y axis on your coordinate plane. Okay, they intersect at the origin. They intersect at a right angle.
We go to intersect them. So the perpendicular lines or slopes are -1.
The product of their slopes are -1. So, for instance, if I had a line.
Thank you for your patience. We can resume movement now. Thank you.
If I have one line with a slope that has 2, the other one then would have to have a slope of -1/2. Okay, so then if I multiply those two together, 2 times -1/2, that's going to be over 1, so you get -2/2 or -1. Okay, the other way you can look at it is if you take one slope, flip it and change the sign, that should be the other slope. Okay, those are negative reciprocals of each other. Right? I'm probably going to use this more often than anything. By definition, if you multiply the two slopes together, you will get -1. But I will use opposite reciprocals or negative reciprocals more so than anything. Okay? Or flip it, change the sign. All right? I'll just write that down here too. Flip it and change sign.
Wouldn't that be keep it with flip it?
No, different. Okay? All right, so there are 3 different types of ways that lines can happen. Didn't put this one in. All right, we good on this one? If I move ahead? Okay. So there's 3 different things that can happen for lines. All right. First one, we can have lines that are parallel. Okay. It's parallel. All right. We can have lines that are perpendicular. So just use these 2. Okay. So these are perpendicular lines. Now, by definition, parallel lines are the only lines that don't intersect, correct? All right. Parallel lines, that's the definition. They do not intersect. Perpendicular lines intersect one time, intersect a certain way. Now, every other pair of lines, will they intersect if they're not parallel? Yeah, at some point they will intersect. Okay, every single pair of lines that are not parallel will intersect somewhere. It might be on your picture, or it might be infinitely out one direction or the other. But unless their slopes are the same, unless they're parallel, every set of pairs of lines will always intersect. All right, so for us, we have 2 special cases. Okay, so these 2 are not parallel, we're perpendicular. So what we just do, we can identify parallel, we can identify perpendicular, and then if it's not one of those special cases, we just call it neither. Right? It's not parallel, it's not perpendicular, so it's just somewhere else. So this probably constitutes probably 95% of all lines that are going to be in this case. Okay, we're worried about these two special cases.
How is it not perpendicular?
Is it intersect at a right angle? So, two very specific things. Do not intersect at a right angle, every other ones that intersect. Okay? The only other they could be laying on top of each other, but then they're just the same line. All right. So those are the three cases we have to worry about. So what we're going to do, the first thing we're going to have is we're going to give it a pair of lines, and we're going to compare them. We want to find whether they are parallel, perpendicular, or neither. This is the first type of problem you're going to have. Parallel, perpendicular, neither. So what you have to do, you have to find the slope of each to determine the relationship. All right. So if you have given a pair of lines and you're asked whether they're parallel, perpendicular, or neither, just find the slope of each one. All right. Sometimes you have to solve for y. I'll write that here. May have solve for y to find slope. Because whenever we're looking at an equation, the only way we can find the slope is this. We have y equals mx plus b format, right? We did this back in lesson 1. Sometimes we had to solve for y to identify what the slope is. So looking at this first one, I got 4y equals negative 5x plus 12, and y equals 4/5 x minus 8. Is this in slope-intercept form, this first one? Is y by itself? No, there's 4 with it. Is this in slope-intercept form? Yes, it is. All right, so the second line's easy. I already know right now that the slope of this line is 4/5. Okay? Slope of that line is 4/5. So the first one, let's find the slope of it. So I need to solve for y. So if I want to solve this guy for y, I have 4y equals negative 5x plus 12. I just need to get rid of that 4. So I want to divide by 4. Now if I do that to one term, I have to do it to every term, right? So y equals negative 5/4 x plus 3. Now that's in slope-intercept form because y is by itself. What's my slope? Negative 5/4. Okay, so the slope of the first line is negative 5/4. The slope of the second line is 4/5. They're parallel, perpendicular, neither. They're perpendicular. Why are they perpendicular? They're negative reciprocals. Yeah, opposite reciprocals. Correct. If I would take this negative 5/4, flip it, change the sign, I'm going to get 4/5, right? So therefore, those two lines are perpendicular. Does that make sense? All right, so the next one. We have y equals 3/4 x plus 7, and 4x minus 3y equals 9. Is either one of those ones already done for us pretty much?
Yeah.
The first one is, right? What's the slope of the first one? 3/4. Okay, it's already in slope-intercept form. So right here, slope is 3/4. Second one, we got to solve that one for y, don't we? All right, so let's take it. I'm going to subtract the 4x over. So I have negative 3y equals negative 4x plus 9. Right? Now we have to do what? You divide everything by negative 3, right? Do it to 1, you do it to all of them. So I have y equals 4/3 x minus 3. What's the slope of this line? 4/3. Now, the slope of the first one is 3/4. Oops. The slope of the second one is 4/3. type of relationship do these guys have? They're reciprocals, but are they opposite reciprocals? No,
Are they needed?
that would be neither, correct. All right, they are not, they're reciprocals, but they're not opposite reciprocals, so it didn't fit all the qualifications. All right, yes, they're reciprocals, but they are not opposite reciprocals. Therefore, it would be neither. That means they somehow intersect, and it's going to be something other than a right angle. Now, if you think about it too, just kind of roughly, it would be like 3, 4. You'd have a slope kind of like this, and the other one would be 4, 3. You'd probably have a slope more like this. Okay? So we gotta get them to be negative of each other to be perpendicular. Questions on that, guys? All right. There's 2 I want you to try. Give you a few minutes to try those. Take it back. Give me 1 second. Number 1, I have 6y equals negative x plus 6 and y equals negative 16x plus 6. Who wants to walk me through this one? All right,
Alright, so
start with the first equation. What do you have to do there?
divide 6 by that.
Yep, divide everything by 6, so then you get y equals what? Just plus 1, right? So what's the slope of that line? Negative 1/6. Now the second line, do I have to do anything to it? Okay. Slope of that line is negative 1/6. It's already in slope-intercept form. Y is by itself, so I'm good. I have a slope of negative 1/6 for both of them, so it is parallel. Now someone asked a question, what about this number at the end? Okay, I don't care about that number at the end. All right, that's irrelevant. That just, for this right here to figure out whether it's parallel, perpendicular, or neither, that doesn't matter. All right, that's just where it crosses the y-axis. So if we're graphing it, we know what they look like. All right, second one. Who's walking me through that one? You just did one. Yep, you got it. So the first equation, do I have to do anything to it? No. What's the slope of it? Just 4. I just need the number. Okay. Second equation, what do I have to do there? Okay, subtract the 12x from both sides. So I have 3y equals negative 12x plus 9. Now what? Divide by 3. Do it to 1, do it everywhere, right? So I have y equals what? Negative 4x plus 3. What's the slope of this guy? Negative 4. So we got a positive 4. We got a negative 4. They're not the same, are they? They're not reciprocals. So it would be what? Neither, right? The reciprocal of 4 would be 1/4. Okay, one's positive, one's negative. Now, the only time that you will have a number that one positive, one negative, and be perpendicular would be 1. Okay? Think about it. If I have 1, well, what's the negative reciprocal of 1? I'd flip it, change the sign. So it'd be negative 1 over 1 or negative 1. Okay? These two are opposite reciprocals of each other. This here, we just have a 4 and a negative 4. Those are just opposites. Okay? I'm only worried about two specific equations, or two specific pairs. Parallel if the slopes are the same, perpendicular if it's opposite reciprocals. This here is everything else. All right? That makes sense. All right, so that's the first type of questions you're going to have. You're going to have 3 types of questions in this lesson. The first one is parallel, perpendicular, neither. All you got to do is look at the slopes. Find the slopes of each equation and compare them. If they're the same, they're parallel. Opposite reciprocals, they're going to be perpendicular. If it's neither of those two special cases, then it's neither. All right, so the next thing you're going to do, you're going to write an equation using a parallel line. So you're going to get a question that looks like the one on the right. Write the equation of the line that passes through the point 12,3 and is parallel to the line y equals 2/3 x minus 1. So what do you have to do? Well, 2 things we need to write an equation of a line. We need a point, we need a slope, right? Look over here on the left. You use the given point, and you use the same slope as the parallel line. We're going to use 2/3. Okay? So we're going to use the point given and the same slope. So looking at this guy, my point is 12,3. Parallel lines have the same slope. So I look at this guy and see the slope of it is 2/3. So my slope is going to be 2/3. Now we have everything we need to write an equation of a line. Put it in your point slope formula. Good. Y minus 3 equals 2/3 x minus 12. All right, then distribute. So y minus 3 is going to be 2/3 x. 12 times 2/3 is going to be 24/3, or 8, correct? And then add the 3, y equals 2/3 x minus 5. And again, we talked about it when we talked about with slope. Yeah, your slope here is 2/3. Don't make 2/3 into 0.67 or 0.6 repeating. Leave it as a fraction. Okay, it's so much easier to graph stuff when it's a slope of 2/3 versus 0.67. All right, so leave it as a fraction. Do the fraction work. I think this one's pretty simple. All right, this is just building on what we've already been doing. You use the point that you're given, and you use the slope of the other equation. You have to be parallel to this guy, so your slope is going to be exactly the same. Does that make sense? All right, so then the rest of it, the only thing that's different here whatsoever is just stealing this slope from here to here. It's the only thing that's different. Everything else is just straight review. Okay? All right, here's 2 for you guys to try. Now, again, this one here, you're in good shape. The slope's already given to you. This one here, you have to find your slope first before you can steal it. All right, so take a minute. All right, first one. So I have my point. What's my slope I'm going to use? 2. Okay, I'm using 2 because it's a parallel line. So I use the same slope as the other line as well. All right, so my point is going to be -3, -1, and my slope is 2. So I'm going to put in the point slope formula, right? So what's that going to look like? Y minus what? Minus the -1 equals, good. All right, so the left side just turns into a plus, right? Right side, after I distribute, what am I left with? 2x plus 6, good. Last step, subtract a 1. So y equals 2x plus 5. Good. Now, looking at this one, the slope of this line is 2, right? What I'm going to tell you on these type of problems, just take a peek right at the end. Make sure that your slope is still 2. All right, if you did something wrong along the way and your slopes are no longer the same, then you need to go back and check it again. All right, you walk me through the second one? Okay, what do you have to do first?
Alright, you gotta do the 4x minus 4x, put it on the other side, and then you
Okay,
gotta
hold on, slow down. Minus 4x. Okay, so then I have 2y equals -4x plus 12, right?
Yep.
Divide by 2. So y equals, okay, so what's the slope of this guy? -2. So then I'm using the point -2, 4, and a slope of -2 for my line, right?
Yeah, so you gotta go y minus 4
Uh-huh,
equals -2
uh-huh.
x minus 2.
X minus a -2, right? Okay, so this is going to turn plus inside. Then when I distribute, what do I get when I distribute?
So it would be -2x
Uh-huh,
plus
yeah, minus 4. All right, last step.
then you got to move the other 4 over,
Yep, plus 4.
and then that would just be y equals -2x.
Yep, y equals -2x. I just don't have a y-intercept, do I? Okay, am I good? Any questions there? All right, I'm going to add one more step now. So we have to identify whether things are parallel, perpendicular, and either. We're going to use a parallel line to make a equation of a line. What's the last thing you think we're going to do? Use a perpendicular, right? We don't want to leave perpendicular lines out. All right, they're going to feel bad. So write an equation using a perpendicular line. So for this one, again, you're going to use the point given, and then you want to use the negative reciprocal of the slope of the perpendicular line. Again, you might have to solve for a slope there. All right. So you're going to steal the equation, or you're going to steal the slope from the other equation they give you. Then I need you to flip it and change the sign before you use the slope then. Okay, because we need our slopes to be negative reciprocals of each other. So looking at this example, I write the equation of a line that passes through the point 2, 4 and is parallel to the line y equals 1/3 x minus 1. All right, so this line that I'm given, this is the one I'm perpendicular to, y equals 1/3 x minus 1. So what's the slope of that line? 1/3. Okay, so then for me, I'm going to have the point 2, 4, which we already found. Now I got to take that 1/3, flip it, change the sign. So what's my slope need to be? -3, perfect. So my slope is -3. I took 1/3, flipped it, changed the sign, and then get a slope of -3. So now I want to use that stuff that I'm given, a point and a slope. So y minus what? 4. My y term equals my slope, which we just found was -3, and then x minus 2. All All right, same process we did before. Slope, point, put it in point slope form. Now distribute the right side. I have y minus 4 equals negative 3x plus 6. Add a 4 to both sides. Y equals negative 3x plus 10. So now, just check it real quick. My slope is negative 3. The slope in the other equation that it's perpendicular to is a positive 1/3. Are they negative reciprocals of each other? Yes, they are. Questions? Anybody? All right, here's the last thing. You guys do those too. Give you a couple minutes to try them. Yep. So, in the first one, we have a point already. We have a point of 1/8, right? Now, what's the slope of the other equation? SB, what's the slope of the other equation? What's the slope of it? Okay. So if that has a slope of 2, I want my line to be perpendicular. What's my slope going to be? Flip it, change the sign. Flip it. So if this is 2, that's 2 over 1. How do you flip that? There we go. -1/2 is going to be your slope that you use then. Okay, so plug it into point slope. I'm going to have y minus, what's my y term? Okay, equals my slope, which is right here, -1/2 times x minus, what's my x term? 1. Okay, so I distribute the right side. So I have y minus 8 on the left, distribute a 1/2 through, what's that going to be then? Okay, so then I have to add an 8 across, right? So it's add an 8 to both sides. So then I'm going to have y equals -1/2 x, and then what's 8 plus 1/2? 8.5. You can just leave it like that. Questions there? All right, who's walking me through the second one? So I have my point, right? 6, -2. Okay, so my slope, what do I have to do with this guy?
You have to subtract the 4x over the 12.
Okay, so I have 2y equals -4x plus 12. Okay,
So then you would divide 2 over to the 4x side and the 12. And then you would have y equals -2x plus 6.
okay, good.
And
So I
then
just
the
solve for
slope,
this. Yep, solve for y to find my slope. What's my slope there now?
-2.
-2.
Positive half.
So my slope's going to be +1/2, correct.
See, so it would be y minus 2 equals 1/2 x minus 6.
Good. Okay, distribute the right side. What do you get?
1/2 x equals or
-3, yep. Last step.
plus 2 over to the 3, and you got y equals 1/2 x minus 1.
Good. All right, and again, like I said, for that last step, check your slope real quick. This is 1/2. Slope of the other guy was -2. Are they negative reciprocals of each other? Yep, so I'm good. In the first one, this guy has a slope of -1/2. Slope of the other one is 2. They are negative reciprocals of each other. Questions, guys? They are. This and this is combined. This and this are combined. Any questions? Y equals 1/2 x minus 1. Yep. Okay, so in your homework, you're going to have some more practice on these. There's 3 types of problems. First one, parallel, perpendicular, neither. Find the slope of each, compare them. If the slopes are the same, they're parallel. Slopes are negative reciprocals of each other, it's perpendicular. If it's neither of those two cases, it would be neither. All right? If you want to find the equation of a line through a point that's parallel to another line, if your line's parallel, steal the slope, use that slope and that point to make your equation. If you're writing an equation of a line that passes through a point and has a perpendicular line, steal the slope from the perpendicular line, flip it, change the sign, and use that in your point for your line. Any questions?